Assuming air has a constant density between the base and at elevation 11 kilometers at a temperature of 15 degrees Celsius and based on normal atmospheric pressure at the base of Mount Apo. Determine the height of Mount Apo if at its peak the barometer reads 495 millimeters of mercury. Column. What is the absolute pressure at elevation 5 kilometers? What is the barometric reading at elevation 7.5 kilometers? So let's have the figure to help analyze the situation. So the base is at normal atmospheric pressure or barometric pressure, which is 101.3 kilopascals absolute. The peak has barometric reading of 495 mm of mercury column. So the pressure there is 13.6, specific weight of mercury 13.6 times 9.81 times 0.495. So that's why we have 66.04 kilopascals. And this is surrounded with air with constant density or constant specific weight gamma of air. Then we sum up pressure from the peak to the base. 66.04 plus specific weight of air times H equals 101.3 kilopascals. So we can compute for H. Now the specific weight of air is pressure, which is at the base 101,300 pascals absolute times G over gas constant of air, then absolute temperature. So this is the equation: pressure at the peak plus gamma of air height of Mount Apo equals pressure at the base, where gamma of air is pressure G over RT. Pressure is 101,300 pascals absolute times 9.81 over 287 gas constant of air Newton meter per kilogram kelvins, then absolute temperature in degrees Celsius plus 273. Specific weight of air therefore is 12.02 newtons per cubic meter or 0.01202 kilonewton per cubic meter. We use it here so that it will be consistent because these are in kilopascals absolute. So substitute 66.04 plus 0.01202 times H equals 101.3. Then we can now compute the height of Mount Apo, which is 2,933 meters. Then in the second question, what is the absolute pressure at elevation 5 kilometers? So still we sum up pressure from elevation 5 kilometers or 5,000 meters, then down to the base, because the specific weight of air is constant as stated in this problem. So pressure at 5 plus 0.01202 times 5,000 equals 101.3. So absolute pressure 5 kilometers at elevation 5 kilometers is 41.20 kilopascals absolute. Then in 10.3 we do the same thing. Pressure at 7.5 absolute plus 0.01202 times 7,500 equals 101.3. Then from there, the pressure is converted into height of mercury column by dividing it by specific weight of mercury, which is 13.6 times 9.81. So 11.15 kilopascals, so the barometric reading is 11.15 over 13.6 times 9.81. This is in meters, so we multiply 1,000 to express it in millimeters. The barometric reading therefore is 83.57 mm of mercury column.